Hello everyone, welcome back to Let's Data Science. We are putting cache-augmented generation head-to-head with classic RAG approach to see if preloading your documents into model's memory can actually beat real-time retrieval. To run these experiments, we used a GPU-powered Google Cloud Workstation with dual A100 GPUs, which is essential because CAG's key-value cache devours VRAM like crazy. First, we cloned the CAG GitHub repository and installed dependencies using Python and pip. We then set up our .env file with tokens for Hugging Face or OpenAI, ran downloads.sh to fetch SQuAD and HotpotQA data, and confirmed our CUDA drivers by checking NVIDIA SMI. All of these steps are just standard Git stuff, pip installing from requirements.txt, and making sure our Python environment recognizes the GPU. We tested multiple scenarios on SQuAD, always keeping the same dataset for both RAG and CAG to keep things fair, but changing max knowledge and max question to see where each approach hits a wall. First, we tried small dataset with max knowledge of 5 and around 100 queries. RAG clocked about 0.576 seconds per query, hitting a similarity score near 0.848. Meanwhile, CAG took around 40 seconds upfront just to preload the docs, had a slightly better similarity at about 0.875, but ended up slower overall with 0.744 seconds per query. Next, we went bigger, setting up max knowledge to 10 and raising it to 200 queries. RAG maintained a quick 0.539 seconds each with a similarity of 0.8207. CAG had an even larger upfront cost, about 90 seconds, and queries averaged around 1.416 seconds. It was a tad more accurate at 0.8339, but that advantage is hard to justify if you don't have thousands of repeated queries. Then we really tried pushing it to max knowledge of 500 using dual A100 GPUs. RAG actually finished the test, showing a 0.785 similarity at about 0.557 seconds per query, and only took around 10 seconds to build the BM25 index. But CAG crashed immediately with an out-of-memory error because loading that many docs into model's context demanded over 44 gigabytes of VRAM. So if your knowledge base is massive, watch out. CAG can be ridiculously expensive in GPU usage. Putting it all together, RAG is typically simpler, cheaper, and remains fast unless your doc set is enormous or you have thousands of queries. CAG might be worth it if you have big, stable dataset and the budget for high VRAM GPUs, especially if you need to answer the same question repeatedly. Otherwise, RAG's overhead is just far less demanding. Now, some people ask if they can do CAG with GPT-4 or another closed model. The short answer is not really. OpenAI's API is stateless, meaning you would have to send all your documents every time, and you can't access the preload or preload the model's internal key value cache. That would be incredibly expensive because you pay for tokens with each prompt, and it still wouldn't be true CAG since the model isn't storing anything for you. Closed models just don't expose that level of control. On top of that, CAG is expensive enough as is in GPU usage. Imagine layering token cost on top of that. Not good. If you want to replicate these experiments, just clone the CAG repo, run the exact Python commands for RAG and CAG with parameters like max knowledge of 5, 10, 500, and compare your logs. Keep a close eye on the VRAM usage. CAG can blow up if your context is too big. Are you still leaning towards RAG, which is simpler and more GPU friendly? Or do you crave that small accuracy boost from CAG enough to handle massive GPUs? Let me know in the comments or drop a message. Thanks for watching. Remember to like and subscribe for more AI and data science content, and I'll see you soon with our next deep dive.